Chapter 8.4, Working with Vectors. As you know, there are two types of quantities. One is vector quantity and other one is scalar quantities. Now, scalar quantities, we know that we have only magnitude and quantities are always positive. So it can be distance, speed, time, mass. Like there are more, but and the vector quantities has both magnitude and direction. So a scalar quantity is only magnitude and it can be negative or positive. Here only in a scalar quantity is only positive. And like example, displacement, velocity, acceleration, uh, force, weight, those all are vector quantities. Um, Before getting into example 6, we'll do a different example first. This is a right angle triangle and let me take this is ABC. Let's say this distance is 16 meter. This is A and this is B, this distance. So, we'll write is AB distance and BC distance. We can work like that as well. So this angle is 60, right? Find AB and BC distance. Now you can see this is hypotenuse, and when you come and stand up here, there are two adjacents. One is this one and other one is this one. This one we'll call hypotenuse, then the other one is adjacent, and this is the opposite. So adjacent and hypotenuse, the ratio is cos. So cos 60 is adjacent, which is AB, divided by AC, hypotenuse. So AB over AC is 16. So AB is 16 cos 60, which is 16 cos 60 is half. This is going to be 8. So this is 8. And sine 60, opposite over hypotenuse, which is BC over AC. BC is BC and AC is 16. So BC is 16 sine 60, which is 16 times square root 3 over 2. That is going to be 8 square root 3. So this distance is 8 square root 3. Now AC vector is given 8i plus 8 square root 3j. Now the vector is given AC equal 8i minus 8 square root j. Now what is the magnitude AC? You know already magnitude is 16 of this one. Now we have to show this one. So magnitude of AC Pythagoras. 8 square plus 8 square root 3 square root. So this is going to be 64, and this is 64 times 3. It means 4 times 64 square root, that is square root 4 square root 64, that is going to be 2, and this is 8 and 16. Now what is the angle? Tan theta is 8 square root 3 over 8. 8 to 8 cancel out, square root 3. So theta equal tan inverse. So we know this is 60 already. Square root 3, this is going to be 60. We found out that. Before go to example 6, we should know two things. Distance is the distance is the magnitude of displacement vector, and the speed is the magnitude of velocity vector. So if you want to find a distance, then you should have the displacement vector and find the magnitude. And if you want to find the speed, so you should have the velocity vector and get the magnitude. So this is something we have to remember. In example 6, it is given V equal 3I plus 5G. And the unit is meter per second. So meter per second we are measuring with the speed and the velocity. So this is the unit. Now we need the speed. First question. Mean magnitude of velocity vector, which is V. How can we find the magnitude of? We know already. So E square plus I square square root. So this is V. V is given like this, 3I and 5G. It's not important for us this 3I and 5G. Only important thing is this V. So when you find the size, we will get the speed of this one, magnitude. So this is square root 34, 5.83. Part B is the angle direction of motion. So we want to find the angle. This is theta, and this is 3I plus 5J, basically 3 and 5. I, and this is J axis. Tan theta equal 5 over 3. So theta equal tan inverse 5 over 3. So approximately 59 degrees. Example 7. It's a walk for A to B to C. So AB, the vector displacement vector on Ci plus 4j, and B to C is given 5I minus 12j. So 6I plus 6I plus 4j and minus 12j plus 5I. So there are, this is I components and this is j components. The total I is 11I and total j is minus 8j. So question A, what is the magnitude of the displacement from A to C? So A to C we are using a triangle law, A to B plus B to C. Then A to B given 6i plus 4j and BC given 5i minus 12j. Then this is 6 plus 5i minus 4 minus 12j. This is 11i plus plus minus 8j plus times minus minus 8j. So we need to find the magnitude of the displacement. So this is the displacement vector. So this is the displacement vector, and mod, we need to get the mod value, that is 11 square plus minus 8 square square root, that is 121 plus 64 185 square root, approximately 13.6 kilometers. Part B, total distance, man walk, it means distance to A to B plus distance to B to C. It means mod AB, the mod value of BC. Mod AB means 6 square plus 4 square square root plus mod BC 5 square plus minus 12 square square root, that is 7.21 plus 13 will make 20.21 kilometers.